I can do that, right? Okay. So the square goes on the numerator as well as the denominator. Let's expand this. You get 1 minus 2 cos 2x plus cos 2x the whole square, and take the 1 by 4 common. Okay? Now there is a problem again. What's the problem? The problem is I have an even power again. That's the problem. It's cos squared 2x. It's a double angle, तो क्या हुआ? But then again there's an even power. So I have to change it again. Using what? I know cos 4x is 2 cos squared 2x minus 1. Double angle, it can be used for 4 2. The ratio has to be 2:1. Okay? So if I can break a 4x into 2x and 2x into x or 6x into 3x, I can do this, right? Okay? So what is a cos squared 2x?
Sir, cos 4x किससे बोला?
सर cos 2x
Double angle.
तो अगर 2 cos square x minus 1 ही डाल दें तो फिर
किसको?
cos 2x की जगह 2 cos square x minus 1 डाल दें।
इसकी जगह क्या डालते हैं?
2 cos square x
minus 1 डाल दें तो और आसान हो जाएगा। बस एक्सपेंड कर दें।
और फिर डायरेक्ट
I didn't get your point.
सर ब्रैकेट में cos 2x है ना?
हाँ.
उसकी जगह 2 cos square x minus 1 डाल दें
क्योंकि आइडेंटिटी है ना।
Then you get, आप उसको स्क्वायर करेंगे तो you get cos 4x. Then again even power आ गई. You're not getting rid of the power. I want to get rid of the power. देखो अगर तुम लोग ये कह रहे हो ना कि अगर मैं यहाँ पर ये कर दूँ 2 cos square x minus 1 whole square. अब जब इसको स्क्वायर करूँगा तो I get a power 4 cos 4x. The problem is with the power. It's not that I have to get this 2x into x. I'm fine with the double angle. I'm not fine with the power. I need to get rid of the power. So use this. A double angle can be used for any angle as long as there is a ratio 2:1. ठीक है? अगर cos 4x है is 2 cos squared 2x minus 1. So can I make cos squared 2x the subject? I can easily do that. It is cos 4x plus 1 upon 2 square. सिर्फ replace किए. This is here as it is. The 1 is there and the 1 by 4 is outside. Now you have to expand once more. ठीक है? 1 by 4 plus there is a 1 by 4 here.
फिर cos square रहेगा।
अच्छा ठीक है वो स्क्वायर नहीं है. The square has been used up. मैंने cos square को यूज किया. ठीक है. I replace the cos square 2x. वो यूज हो चुका है. ठीक है. What am I left with? Half cos 4x plus half. By you can split it, right? Cos 4x upon 2 plus half. Ravisha, you can do that, right? ठीक है. Now it's easy to integrate. ठीक है. You can simplify if you want to. You can open up the bracket or you can just integrate right away and let's see what happens. Let me keep the 1 by 4 outside. One key integration is x. What about cos 2x? It's sin 2x upon 2. ठीक है. What about cos 4x? It's sin 4x upon 4 plus half x. Obviously plus is indefinite integrals. ठीक है. Now if you simplify this result, you have the integration. The problem was the power, even or odd. It's not with a double angle. You can deal with the double angle easily.
Sir, अगर cos 2x को होल स्क्वायर आपने किया है
किस वाले
ब्रैकेट
ये वाला
नहीं
नीचे वाला
नीचे आप बिल्कुल राइट पे देखिए लास्ट में cos 2x होल स्क्वायर लिखा हुआ है
हाँ
इसको अगर मतलब कि स्क्वायर आपने किया तो ये बन गया cos स्क्वायर 2x
2x या
cos स्क्वायर 4x नहीं होगा ये
नहीं
cos स्क्वायर 2x
it doesn't go on the angle
ओ सही
ठीक है even power is a thing where we started from we have no way of doing this directly we have to split it acha so let's just simplify this thing you have 3 by 2x minus sin 2x plus 1 by 8 sin 4x plus c ठीक है it's 3 by 12x minus 1 by 4 sin 2x plus 1 by 32 sin 4x plus c. That's your final result.
3/8.
Yes, yes, same on it.
3.8, sorry. Are you fine with this? Dead. As usual. Yeah, right. It's procedural. You have to get rid of the powers. You have to get rid of the powers. And you know this identity helps you. You know you can change a power into a double angle. A double angle can be dealt with, but not the power. So you just replacing systematically. जहाँ power आ जाती है, you use the double angle appropriately and you get rid of the power. You had a power 4, right? So you had to make the substitution twice to reduce the power. Agar in the previous cases you had sin square x, you did the substitution once and it went away. You get the idea? Okay. Let's try part D. Part D में you have something similar. You have cos square x.
Cos 2x plus
ठीक है? This will be cos 2x plus 1 upon 2 whole square. Simple substitution. So you have 1 by 4 and I'll expand the numerator. Cos square 2x plus 2 cos 2x plus 1. Simple expansion. ठीक है? Then again, this is my problematic term. Square आ गया, ठीक है? But I can easily get rid of that using a simple manipulation. That's cos 4x can be written as 2 cos square 2x minus 1. So cos square 2x, I can make this a subject. It can be easily replaced as cos 4x plus 1 over 2. ठीक है? इसमें तो कोई मसला नहीं है, ठीक है? So I can simplify this thing as half cos 4x plus half, just one step. ठीक है? Now I can start integrating. Let the 1 by 4 be outside.
हाफ sin 4x
कौन सा?
हाफ से प्लस होगा प्लस 2 cos 2x ब्रैकेट में
Plus, yeah, plus. ठीक है? So
3/2. 3/2 देना है.
ये कौन हाँ ठीक है कर लेंगे. Let's ये क्या? ठीक है?
Sin 4x upon 4.
Sin 4x upon 4.
So ये क्या 1 क्यों हटा?
Plus 1 क्यों हटा दिया? There was a half here and a 1 here. You can combine them as 3 by 2. 1.5. ठीक है? It's 3 by 2x plus cos 2x integration is sin 2x con 2
Plus c.
plus c. 2 and the 2 goes away. And 1 by 4, 1 by 8 sin 4x plus 3 by 2x plus sin 2x plus c. Now you can open the bracket up if you want and simplify it further. 1 by 32 sin 4x plus 3 by 8 x plus 1 by 4 sin 2x plus c. That's the final result. थोड़ा आगे चलें। You'll have to replace it thrice. Same procedure, you'll have to split it, then split it, then split it. Procedure same रहेगा. You have to do it, but you have to replace it multiple times. अब इस बार 2 दफा replace करना पड़ेगा, double angle use करना पड़ेगा. You have to use it 3 times. This topic is included. Yeah. Integration 4, integration 5, and differential equations. We're going to complete integration 4 today. Yeah. Everything.
सर मैं तो डबल एंगल क्या यूज कर रहा हूं?
नहीं. Differentiation, all of integration and differential equations is coming in the box. Complex numbers नहीं है. बाकी सब तो है.
सर कैलकुलस
Everything. Let's move on. Case 3. The first case was odd powers of sin cos. The second case was even powers of sin cos. The third case is powers of tan. You don't have split cases for this. There's just one case. It says make use of tan square x is equal to secant square x minus 1. Make use of this identity. In case of powers higher than tan square x, separate a tan square x as a product. Okay, and use the identity again to convert it. Let's see how we use it. Let's say tan square x, it says use the identity, which is secant square x minus 1. I can integrate this thing. Secant square x की integration is what? Tan x minus x plus c. Relatively straightforward. आप लिख के दे दो ना क्या करें? I don't think you're making how.
इस बार भी P3 और S2 साथ होगा पिछले साल आपने P1 और S2 साथ किया अलग अलग दिन है ना
अच्छी बात है
I think getting clear. I don't think I know it's somewhere towards the end. At the edge of the I don't know. अच्छा let's try part B. किसका नाम है? अच्छा, let's try integrating tan cube x. ठीक है? The procedure says separate the tan square x. ठीक है? Let's do that. Just don't try to remember the procedure. Just see what the procedure is trying to do. ठीक है? It's trying to induce a certain form that you've already done. We're not teaching any new techniques. Techniques 1, 2, 3 में हो गई. Just applying those techniques onto different situations. You'll see how. This is tan cube x. ठीक है? Now it says use this identity to convert the pulled out tan square x. Let's do that. So you have secant square x minus 1 into tan x. ठीक है? Now let's दो brackets है, what can we do? Multiply कर सकते हैं. Let's do that. What do I do next? देखो, do you see a particular form?
Yes.
Tan का differential है secant square. The exact differential is in the product. It's product form 2. So how do you integrate that?
Add 1 to
Add 1 to the power. Divide by the new power. इसका तो काम खत्म हो गया. ठीक है? And what about this? It's if I'm not wrong, it's ln secant x. मुझे भी याद to be honest. पता नहीं. अच्छा, yeah. It's ln secant x. It's ln secant x. Yeah, it's ln secant x.
Okay.
ठीक है? So you can easily do this.
Tan x को differential है.
Yeah, integral है. Direct integral है.
कैसे नहीं करेंगे? secant को square नहीं करेंगे.
Secant को
square नहीं करेंगे.
देखो, tan का differential secant square है. Tan का differential is secant square. So you add and divide the new power here, not here. अरे बाबा ये इससे प्रोडक्ट आप उसी की फॉर्म में लिख दो यार. x into y, y into x, it's xy, yx. क्या की? tan स्क्वायर को secant स्क्वायर एक्सपांड कर दिया. यहाँ पर इसकी इंटीग्रेशन है, इसकी डायरेक्ट इंटीग्रेशन है. अब इसको इंटीग्रेशन आपको की होगी sin x over cos x. cos का डिफरेंशियल इज sin. तो sin ऊपर है, माइनस इंड्यूस करो तो ns पूरा फॉर्म आ जाएगा. Are you fine with this? You're not fine with math at all.
So this should not be through.
Right? Such a guy, you can have good. I don't mind. write it down.
Yeah, because we just did it, we need more practice for doctor.
Yeah. Why you have a study week for that?
Yeah, 2 days.
सर स्टडी में आप कॉलेज में होंगे स्टडी में आप कॉलेज में होंगे
जाना करें।
हम किससे पढ़ेंगे
Let's do this last part. We are done.
We're done with integration 4.
Yeah, this is the last part. अच्छा,
That's for 11.
you can write tan 4x as this. अब दोनों are equal. Replace any one of them with secant square x minus 1.
दोनों क्यों नहीं करेंगे?
नहीं देखो, you trying to induce a certain form. अगर आप इसको भी कर दोगे change, then you end up with secant power 4. ठीक है? हाँ ना, but उस square से मुझे फर्क नहीं पड़ता. So that's the exact differential of tan. If I multiply this thing, all to the same. I get this tan square x, secant square x minus tan square minus. ठीक है? अब I can write this as tan x. I can do this. ठीक है? It's a function raised to a power, and the exact differential is in the product.
So tan के differential is that secant.
Secant square. So tan x to the power 3 upon 3. And do you see this tan square x? This is the first thing we did. अगर आप question में करें तो obviously we'll have to start the procedure for a square from there. यहाँ पर you can just use the result of part A and just क्या है? What was the result actually? Tan x minus x. Simple, right?
Yes, sir.
Very easy, right?